Let's start with a quick note on domains. So, if we're given a problem like this, the integral of 1 on x, we can think of this as like the original function. And the original function will have an implied domain. For example, here, what value can x not be?
0.
Yeah, so there's this sort of implied domain that 1 on x is a function, providing x is not equal to 0. Once we integrate, this implied domain needs to carry through as well, and we might restrict the domain further. For example, the integral of 1 on x is ln x plus c. Now, the domain of the integral must include this and might have further restrictions as well. In this particular case, its domain is strictly greater than 0. We can't log a negative and we can't log 0. So in this case here, we introduce a new domain. You might see this in the answers as you go through, where the integral of this is this and domain introduced. The examiners historically haven't asked much about it, but I had a look through the course content and it's kind of a grey area whether they could ask a question or not. So it's definitely worth learning. The guiding principle is you can restrict a domain, but you can't free one up. And I'll try and show you that here. If you have the original function as 1 on root x, that is really the same as x to the minus half. What is the domain restriction here? Good. Strictly x is greater than 0. Can't equal 0. Yeah? So the original function has an implied domain of x is greater than 0. If we were to integrate this, what's the integral of that?
X to the half on...
Good. Is x to the positive a half?
Yeah,
2.
negative 2. A half, 2.
Good. Who practiced? Alright. Plus c. So the idea is that negative a half must have come from positive a half. If you were to differentiate this, that positive a half would throw a half out the front, but we have no half out the front here, so it needs to be a 2 to like cancel out that positive a half. What's interesting is, I mean, we would often write this as 2 root x plus c. What is the implied domain here? The implied domain, meaning the possible values for x, is normally it would be x is greater than or equal to 0, because you can square root of 0. The problem is that was the original domain and 0 was excluded. When we integrate, we can't suddenly include 0. The original function didn't include 0, and therefore its integral also cannot include 0, meaning the domain is still that. Does that make some sense? So if you have a domain restriction initially, you can include more restrictions like here, but you can't free it up. You can't add things in. So in this case here, we would have added 0 in if we had greater than or equal to 0. No. Yes, that's going to look odd on the video. She asked if that was me. All right. So we are going to start looking at the first and only integration technique you guys need for this year. There are lots of different integration techniques, and as you go up through maths, if you do more maths next year in university or the year after, etc., you will learn more techniques here. But we only do one in methods. But before I dive into it, I thought I would show you one of my favorite. Have you guys seen Friends? Seriously? All right. Some integrals are very easy. For example, the integral of 1 on x to the 5. If we are integrating x to the negative 5 dx, what's the integral of that? Where will it come from?
Negative 4.
Good, it will come from a neg 4. And what do I put out the front to cancel the neg 4 that will drop down the front? Good, negative a fourth plus c. Alright, so the integral of x to the neg 5 is pretty easy. Joey's pretty happy with it. x to the negative 5 plus 1 is a different ball game altogether. This is a quick video. And as soon as you see the fact it's 40 minutes, you can sort of understand the pain we're going for. They start with this, 1 plus x to the power of 5, and 40 minutes later, they end up with the solution.
Can't you just split the fraction?
No! No!
Yeah.
I think you start by splitting the fraction, but it's not pretty.
Yeah.
They do add a plus c very satisfyingly on the end. So, being clear here, there is a very fine line between an easy integral and a very difficult integral. That is a very difficult integral.
Why can't you just split the fraction?
Yeah,
You've got to
okay.
get the bottom the same, Andrew, right?
What?
You've got to get the bottom the same.
So I'm worried that when you say splitting the fraction, people are thinking you can do this. Are you thinking I can do this?
I was for a second, but now I realise that's definitely very wrong.
You can't do that with fractions. Because if you were to add these back together,
Yeah.
they don't add to that. They don't have a common denominator.
If it was on the top though, it'd be fine. If it was
Yeah, on the top we can split, but we can't split on the bottom like that. It's good. Glad we cleaned that one. Oh, it finished. All right, so methods teaches you one technique. Yes.
Where does the tan come from?
Well, you can go back and watch it if you want. There are other fair points, like where does a lot of it come from?
Wait, sir.
Feel free to watch it, but it's certainly beyond the course.
Focus in the test.
All right. So, one common integration strategy is differentiate and hence integrate. And you'll see this pattern of words come up again and again. They will tell you to differentiate something and then use that derivative to try and spot an integral. Now, that doesn't make a huge amount of sense when I say it the first time, but we're going to do some practice on it, and hopefully it'll become clear. So there's some space under this. Find the derivative of x sine x, and hence determine the integral of x cos x. So the first step is finding the derivative, d dx, of x sine x. What do we do here? It's differentiating, so it's what we've been doing for a while. Product. U is x, v is sine x, u dash is 1, v dash is cos x. Therefore, d dx equals u dash v x plus x cos x. All right. When they say differentiate, hence integrate, what they're meaning is they're giving you something and something else here. We know that if we differentiate, it's going this way. Going backwards is integrating. So what they are really telling us is that the integral of sine x plus x cos x dx is equal to x sine x. If we differentiate this and get this, we can integrate this and go back plus c. For some reason we leave the plus c up at this stage, because we'll introduce it at the end. But does that make sense? If we differentiate to get there, we can take this and integrate it and go back. Yeah? Now, what they've asked us to do is find the integral of x cos x. And that's part of our thing. And we know that if we add two together, we can split it. So really, this becomes the integral of sine x dx plus the integral of x cos x dx equals x sine x. We're not going to end up integrating this directly. Instead, we're going to get it on its own, and that will tell us the answer. So,
not just integrate it?
not directly.
Why not?
Well, it's fairly difficult to integrate directly. So really integrating directly is saying, what function when you differentiate gives you x cos x? And then you have to think in your head of a function that will simplify down once you differentiate it to x cos x.
Is that not x cos x squared?
No, Okay, well I mean, it's worth thinking about it. So if we differentiate x, you want to do that?
But is x cos x not x cos x squared?
I mean,
But like,
no,
With a 2 at the front, you mean?
because it's like,
Yeah.
there's a times there.
okay, yeah, don't, yeah, don't worry.
Okay.
Yeah.
It is kind of tricky to think of some function that will end up there.
Can we cos x to the x squared and then the x comes out the front and then
Okay, yeah, so cos x to the x squared.
yeah, cos x to the x. No, cos x to the x squared. Like forget the x out the front. And then cos x to the power of x squared. Because wouldn't that be an x out the front? And then
Cos x doesn't derive.
Oh,
Okay,
yeah.
cos x derives to minus sine x,
Yeah.
and there will be the derivative of that coming out.
Yeah, no, never mind.
So trying to do them directly is actually really difficult because you're trying to think of something that will end up there after differentiating. And this is the reason they give you a hint. This and hence, yeah?
Why can't they split like the other things? Like why can't you have?
The splits only work with times and with plus and minus.
Okay.
So yeah, because I guess the reason is this will have come from a product rule or something similar. So the product rule is different, but when you have a plus or minus, you can split and attack it separately. Anyway, to here, we can solve this bit here. What is the integral of sine x?
Minus cos x.
Minus cos x, good. So this becomes minus cos x plus the integral of x cos x dx equals x.
You do the same thing.
It's a bit frustrating because there's no rules to follow like differentiation. So there is no way, and I'll be very clear here, there's no way methods would ask you to say, hey, integrate that. Because there's no way you're going to guess that the integral of that actually is that. And there's not a comfortable way to do it. What they could say is differentiate this, hence know that its integral is that. So they will give you leads into the answer. They're not expecting you to know non-standard ones like that. Also note, 2 ln x would have been very easy to integrate. That plus 1 makes it a whole lot more brutal. A bit like the 1 on x to the 5 plus 1. Alright, last bit of new stuff for today, I figure we blitz at the start and then you guys can work, is, what about this c? Alright, what's happened here is you're given a derivative and asked to find the original function. You guys might remember in the first couple of sats where we did drawing derivatives, or if we give you the derivative, ask you to draw the original function, and you know that original function can change in height. That's because we didn't know the c value, and that effectively changes the height. If they want you to find c, they need to give you some other piece of information. That piece of other information is normally a point. This point here, 0, 2. So what they've given you is the derivative, ask you to find the original function, and then substitute to find c. So what they're effectively asking you to do is integrate x cubed minus 2x squared plus 3 dx. And then we're going to hunt c after that. And this is good revision for last lesson. Do you want me to write it with little separate integral signs, or are you happy just to attack each one? Hopefully it's happy. What's the integral of x cubed?
1 on 4x.
Lovely. 1 on 4 x to the 4. What's the integral of minus 2x squared?
Minus 2 on 3x to the 3.
Yes. And integral of 3? Cool. Plus c. So that is f of x. If you take f dash and integrate it, you get f. And now we want the c. And the c is saying when x is 0, the entire function is 2. So what is c? Yeah, 2. 1 on 4, 0 to the 4, minus 2 on 3, 0 to the 3, plus 3 lots of 0, plus c equals 2. Therefore, C equals 2. So, there are cases where you can find the C.
And then you have to write out the whole equation.
Probably, yeah. I'm not, but yeah, you do. If they wanted f of x, you would have to write that but with a 2 there. Yeah. And that would be an annoying way to lose a mark, actually. All right. F dash x is 2x, 2 sine x, take root x. Here we're going to integrate 2 sine x, take root x dx. In this case, I would actually split it to think about it separately. I would think of this as 2 integral of sine x dx minus the integral of x to the half dx. And then, where does sine come from? What integrates give us sine? Negative cos, yep. So then it becomes minus 2 cos x. X to the half came from and x to the 3 on 2, and therefore we need a 2 on 3 to cancel it out the front. Plus c. Then you're told, and they've chosen a very nice value for you, when you sub in 0, the result is 4. So, 4 equals minus 2 cos of 0, minus 2 on 3, 0 to the 3 on 2 plus c. Working out, what is cos of 0? 1. So it's 4 equals minus 2, that's 0, plus c. C is equal to 6.
Did it actually?
I'm getting FOMO.
Chemistry test, but did you check?
I did.
Was it the savagery
I don't want
promise?
to look at
No, don't even.
Better than last
I think
time.
we're gonna keep it a secret.
What?
Yeah.
Better than last? What? Better than something in the past. I don't know what grade it is. Oh. I think it's an accurate.
I'm turn off the photo camera.